Hi, Sumaya. Should we start?
Hi, yeah.
Okay, so we need to do question number 4C from the question paper and 2B from the assignment. Which one would you want to start first?
The one from the question paper.
Okay, so I think you have to just maybe give a brief idea about what normalization is, what is one normalization form, two normalization forms, three normalization form, etc. And probably just a little bit about functional, what is that called? Functional dependency, right? Yeah, functional
Yeah.
dependency.
Um. Okay. So, I'll share the textbook.
Okay.
Okay. So, functional dependency is basically when an attribute in the table depends on another attribute.
Yeah.
So, for example, student enrollment number and student name, and student address.
Mm-hmm.
So, if two rows of the table have the same enrollment number, they would also have the same name and the same address. So the student enrollment number determines the student name and student address.
Okay. It's denoted by the arrow operator, right? Like if I
Yeah,
say X,
like this.
uh, arrow Y, it means the attribute X depends on Y.
No. X arrow Y means Y depends on X and X determines Y.
Okay.
Like student name depends on student enrollment number and student enrollment number determines the student name.
Okay.
This is also called the determinant.
Okay.
Okay, so that's basically functional dependency. And so we have normalization using functional dependencies. The first normal form is when the following hold true. There are no duplicate rows or tuples in the relation. Each data value stored in the relation is single valued. Entries in a column are of the same type.
Okay. The main thing about first NF is I think that every attribute should be atomic, which means should be single valued attribute,
Yeah,
not multi-valued.
yeah.
Okay.
And it must have a key which could be a composite key of multiple attributes.
Okay.
The second normal form is the relation should fulfill the criteria of the first normal form, and all those attributes which are not part of any primary key are fully functionally dependent on the primary keys.
Okay.
So the main thing here is that it should be fully all of the non-primary key attributes should
Mhm.
be fully dependent on the primary keys. So in some cases, you might have attributes that are partially dependent.
Mhm.
Like for example, in this relation, the primary key is student enrollment number plus course number,
Mhm.
and
You mean composite key?
yeah, it's a composite key. And these attributes, course name, course instructor, they are dependent only on the course number. not on the student enrollment number. So that's a partial dependency.
So that's why it's not 2NF. It's
Yeah, it's not second normal.
okay.
And so they've split it up into student, which has the student details, and course.
Hmm.
Course which has course number, course name, course instructor, and instructor office. So that is in second normal form. Then for the relation to be in third normal form, it needs to be in 2NF, and
Hmm.
every non-key attribute of the relation is non-transitively dependent on the primary key of the relation.
What does that
Uh,
mean?
so a transitive dependence is when A determines B and B determines C. So by the property of transitivity, we can say that A determines C.
Okay, because you can derive C via A, because you can derive A B via A, and then this C via B. So which means A via C can be derived. Correct.
Yeah.
If
So
it was
in
A arrow B and D arrow C, then this was not transitive. A and C, because you can't derive C with A. Correct.
yeah.
Okay.
So in third normal form, um, you shouldn't have transitively dependent attributes.
Okay.
All of the non-prime attributes, all of the non-key attributes should be directly dependent on the key.
Okay. When we say prime and non-prime, I think non-prime are the ones which are not part of the composite key. Correct?
Yeah, yeah.
Okay.
So in this relation, uh, the the instructor office is a transitive dependency. It it depends transitively on course number. So it's not in third normal form.
Okay.
So this table is decomposed into two tables: course and instructor, which has
Can
the
you,
instructor office
would you be able
attribute.
to solve it, like solve that question paper now, since we've
Yeah.
got some idea about it? Okay. It was very confusing, isn't it? Not very simple. Or
Yeah,
was
a little bit.
okay.
Okay, just a second. I'll just put the question on the whiteboard.
Okay. The high chances, I think this question can come in the examination.
Yeah, there was a similar one in the assignment also.
Hmm. There is there? Which one?
Uh, I don't know which one. I don't have the assignment now, but it was there.
Okay.
Consider the relation R equals A, B, C, D, E, and the set of functional
A, B, C, D,
dependencies.
E are basically your columns, right?
Yeah.
Okay.
A determines B, C, B determines E, C determines D. What is the key in R? So we have to find out the attributes or the set of attributes that determine all of the columns in the relation.
Okay. All of the attributes. Okay.
Yeah. So the all of the attributes that are determined by a certain attribute is called the closure, and it's denoted like this. So all
Sorry,
of the
can you?
attributes, sorry,
No, what is the closure?
all of the attributes that are determined uh, uh, by A. So the closure of A is all of the attributes that are determined by A.
Okay.
So so an attribute would also determine itself. So
Mm-hmm.
A,
That's why we can write
and
A.
then B and C from the dependencies that were given.
Right. Because A determines B and C as per the question paper, right?
Yeah. Then
Okay.
B determines E. So uh, and A determines B. So A also determines E.
Yeah. And we can write D also, I think,
Yeah.
because A determines C and C determines D.
Yeah. So
Okay.
it determines all of the attributes in the relation. So
Um,
it's a candidate key or the primary key of the relation.
okay.
So A is the key, and then decompose R into 2NF and 3NF.
So do we not need to find out whether it's like which NF is it? Where NF?
Yeah, we need to find out.
Okay.
So uh, it's its first normal form, and so for second normal form, no non-prime attribute should be partially dependent on the primary key.
Hmm.
So all of the non-prime attributes are dependent on A,
Hmm.
and A is not composite, so there's no question of partially dependent.
Uh, which are the non-prime attributes here? Because I see that
B,
everything.
C, B, C, D, and E. A is the key. That's what we found out from the first
Oh
question.
yes, yeah, you're right. You're right. Yes. So A is the key. That is why others like B, C, D, E, D are not present in A. That is why they are called non-prime attribute, and A is prime attribute. Correct?
Yeah.
Okay. So what did we establish once we know this? That it's not a 2NF because it's not doesn't meet that requirement.
No, it is 2NF actually. It's
No, he's
already in
saying
2NF.
decompose into 2NF.
Yeah, but it's already in 2NF because B, C, D, and E are fully dependent on A.
What was the condition for 2NF?
There should be all of the non-prime attributes should be fully dependent uh, on the primary key.
Okay.
So it's already in 2NF, just this one relation. And
We are 100% sure about this answer, right? Like, have you seen that in any of the solution papers or anything?
yeah,
Okay.
I used some online tool to decompose into 2NF and 3NF.
Okay. Can you share the link of the online tool also later after explaining?
Yeah. So
Just
we have to decompose it into 3NF.
hmm.
It's not
So
already in
not-
3NF because We have transitive dependencies, like A determines B and then B determines E. So A uh, transitively determines E.
Okay.
So we have to remove those.
Okay.
Um, so using the three functional dependencies we have, we can decompose it into three relations.
Mm-hmm.
R1 with primary key A
Okay.
and BC are directly dependent.
So you didn't start the bracket. I was wondering what's happening.
Uh, and we can't put any of the other attributes in here because they're transitively dependent. So we have to make a
Why
separate
did they
relation.
choose only A, B, and C?
Because B and C are
Mm.
directly dependent on A.
Okay, but
We can't
others are
put,
not.
yeah,
Okay.
so those we'll have to put separately.
Okay. I think this will go with the B and E, right?
Yeah,
And will there be any primary key in this? No.
there has to be a primary key. It would have to be B because uh, E depends on B.
Okay. So we are decomposing it into three relations.
Yeah.
Okay. I hope I can solve this in exam. It looks really confusing.
Once you understand it, it's not really that confusing.
Okay. I watched
And the
some online
last one,
tutorials, but they were like nobody has like explained it well.
did you watch videos by Gate Smashers? They have good videos.
I watched it. I watched one NF, two NF. There was a problem with the video. I think he was explaining something and the audio was playing somewhere else.
Oh.
So I closed that.
So this is 3NF.
Yes, this is understood. That's it. Is that all we have to do?
Yeah.
Okay. I think it'd be better if we do one more example. Do we have any online tool where we have, maybe you don't have to like do it, but just explain any of the examples. Are there any other online examples available?
I'd come across some.
Okay. Or you saying there was one in the question paper? Was it same?
In the assignment.
Yeah, assignment. Sorry.
Okay, I'll check the one in the assignment.
Okay.
It's a little different.
Which one are you referring? Which question number?
Question 4. Question 4A.
Four, two. Consider the relations at a function depend. What is the key? No, it's the same. How is it different?
No, it's a little different. The last functional dependency is different and it has an extra attribute F.
Okay, can we try this one?
Yeah.
Try this one.
So here again, I think the key is A.
Are you solving?
A, A determines B C, and B determines E, so A also determines E. C determines D F, so A also determines D F. A determines all of them, A B C D E F. So that's the primary key.
A is primary key.
Yeah,
Okay.
and then A is the primary key. So
Are
again,
there any functional
this
attributes which are not dependent on A?
all of them are dependent on A, so it's in second normal form already.
Okay, good. Uh,
Then we have to decompose it into three, third and
mm-hmm.
so we can make a relation 1 A B C is the
Mm-hmm.
primary key. Relation 2 uh, B E, and
Mm-hmm.
relation 3 C D F.
Okay.
So that is the third normal form.
Mm-hmm. I'm going to share my screen. Okay.
Okay.
See in this solution, I'm going to zoom it in a bit. First, we found the candidate key and find out the closure of the key. They are saying AB is the candidate key.
Mm, but A could be the key alone, right?
Yeah, I mean, according to you, it is, but I don't know why they're saying it's AB plus, sorry, AB is the candidate key.
Candidate key should be non-reusable. So
Mm-hmm.
if you take away an attribute from the candidate key, that means it's not a key anymore.
Mm-hmm. One primary attribute is fully primary key attribute, R1, R2, 2NF, not partial dependency.
Oh, and they have four relations.
Yeah, ABC, and in R2 they have BE, then they have CDF, and they also have AB. I don't know why they have the relation 4. Oh, God, so much they've written here. There's no question even asking all of that stuff. Okay, share any online one na, if you found.
This is the normalization tool that I was talking about. I sent it in the chat.
Okay. Why don't you only show it? I may not be able to use it. I'll stop the share. You can share your
Okay.
screen and maybe solve the one in the question paper. Sorry, the second one through the normalization tool and see what it's giving.
Okay. So what were the attributes? A, B, C, D, E, F.
So let me see. Hold on. So A B C D E F, yes.
And A,
A determines B C.
B, C.
B determines E, and C determines DF. Did they say what is the key?
Uh, oh,
Find out
find
the
out
candidate.
candidate.
Uh,
It's A.
A. So you are right. So that means they
Yeah,
are saying incorrect.
yeah. And the table is in 2NF already.
Yeah. Okay. Let's check the 3NF. So where is the relation? Yeah. Now they have the relation. So do they have the same relation as we had?
They have relation BE and CDF. This is a little confusing because they're not showing the final relations.
They are not showing final.
Okay, relation 2, relation 4, and relation 5 are their final relations. So BE and CDF and ABC, which were what we had, right?
Yeah, how did they like? Is it the same or a different? Different, right?
The same as what?
As we had.
It's the same.
Okay.
Like first, uh, sending table relation 2, which is BE,
Hmm.
and then relation 4, which is CDF. So we had those two tables,
Hmm.
and last was relation 5, which is ABC.
They have five relations, you mean?
Uh, those are during the steps, like they're decomposing each relation into two relation, and then decomposing it further, and then if it's in third normal form, sending it to output.
Okay.
They've sent only three tables to output.
Okay. So the first one is BE, right?
Yeah.
First one should have been BC, right? That's what we had.
No, we had BE.
Okay. And then the second one,
The second one is this one, CDF,
you can third.
ABC.
Okay. Why is the for ABC not the first? I mean, couldn't we start it from there?
You could start. It's just this algorithm is
Okay.
the way it's decomposing it.
Fine. Fine. No problem. Okay. Let's move on to the next question, which is converting the ER diagram into tables, which is the question number 2B from the assignment.
Yeah. So the ER diagram, I'm not sure if I did it properly. Let me show you what I did.
So you derive the table basically out of that.
Okay, so I made four entities: medicine, stock, order, and supplier.
Mm-hmm.
So we'll start by making the medicine table.
Okay.
The primary key is medicine code.
We have to write the schema first, you mean? The schema.
Yeah,
Okay. When we are defining schema, I think we have to write the data type also.
so in medicine, you just need the primary key and the other attributes.
Mhm.
Then stock has a one-to-many relationship with medicine, so it will need to have a foreign key that references medicine.
Okay. So foreign key will be medicine code, correct?
Yeah,
Are you not putting the data type before that?
in the schema,
Yeah.
it's not there in the textbook.
Okay.
Like when they have listed out relations, they've just written the names of the attributes and what are the primary keys and foreign keys.
Okay. So the question says, you're doing the assignment question number 2B, right?
Yeah,
It says design normalized tables in 3NF from the ER diagram drawn in part A with the required integrity constraints. You put medicine code also. Yeah.
yeah, and order ID also because it has a one many-to-one relationship with order.
Okay.
So
So
metcode
then
is the
two
foreign
foreign
key.
keys.
Yeah,
Will there be two? No, actually order ID will not be foreign key. There's only one foreign key, right?
order ID is also a foreign key that's referencing the order entity.
Okay, so when we create the order entity schema, then what will be the primary key for the order? Will be the order ID, correct?
Yeah,
Okay. So that's why there are two foreign keys, med code and order ID.
yeah. The foreign key goes on the many side of the one-to-many relationship.
Okay.
Order has order ID, primary key, and order date and supplier ID. because it has a one-to-many relationship with supplier. So this is a foreign key that references supplier.
Okay.
Oh, they should have been supplier code, supplier ID. Supplier has code name, address, and contact number. And supplier also has a multi-valued attribute meds available. So we have to make a separate table for that.
When we have multi-value, we have to create separate table for that.
Yeah. So this will have a foreign key referencing supplier
Hmm.
and another foreign key uh, referencing medicine. And its primary key will be both of these.
Yeah, that's a composite key.
Yeah.
So we have to underline them together.
Uh, Not necessarily together, but both have to be underlined.
Okay. You probably have to explain them in the notes part in the question.
Yeah, you should write notes of what the primary key and foreign keys are.
Okay.
So that's all, and
But it says
this is
draw.
already in. It's already in third normal form,
Okay.
so we don't have to convert it further because uh, you can see that all of the non-key attributes they directly depend on the key.
What are the integrity constraints?
Uh, I don't know what they mean by that. Integrity constraints are uh, like
Set of
entity
rules.
integrity constraint is
Set of
there's
rules.
entity integrity constraint, which is a primary key cannot take a null value, and
Hmm.
referential integrity constraint, which is
Right.
like a foreign key constraint.
Right. Now my question is that the question number 2B says design a table, but here we have designed a schema. So we don't have to write a table.
Um, I'm not sure.
I'll show you. Wait, hold on.
So in a table also basically the same information will be there, right?
And then we'll be able to add the integrity constraint. No? I'll show you. See, if you define a table, you can write the integrity constraints, which means what is the range of values that are accepted, varchar, and then 20 up to 20 characters, int up to 10 characters, right?
Yeah,
So I think,
that's called domain constraint.
yeah, right. So it's asking to draw table. I think we should draw table besides writing the schema also.
Yeah, that makes sense. And we can clearly explain the what are the primary keys and foreign keys also in a table.
See, this is a structure, right? If you go to structure, you're looking at my screen.
Yeah.
So this is the structure of the table. So name, type, attributes, null, yes or no, default value. So I think that's what we have to draw.
Okay.
This browse is actually adding the data, which is not something you have to do. You have to draw the structure of the table. Okay, can we do this one also? This last one. Convert the diagram to relations.
Yes. But
Okay.
I haven't drawn the AR diagram for it.
Uh, okay. Maybe we can keep this for tomorrow. Then
Okay.
let me see if we have covered everything. So list all the identities. We did this. We did this. Relationship is done. AR diagram is done. Yeah, this last one will remaining. We'll do that tomorrow. Let's take a 15 minutes break. Anything else we were supposed to cover?
No, it was just those two questions.
Okay. So let's take a 15 minutes break and let's come back and then do our regular Java. I think we are very close. Let me see how many chapters, like how many slides are left. So we were here 154, 204. Yeah, not many. We've covered more than 60 to 65%. So there are around 207 slides and we already done 154. So let's go finish this. Cool, then let's catch up in 15 minutes. I'll
Okay.
keep this running. Okay. Okay, so let's do the recap. It's just too much. Where do we start from? I think we can do from string class. Okay, so a string class represents a character strings. One second. Settings. A string class represents character strings. All string literals in Java programs such as A, B, C are implemented as an instance of this class. So a string class represents character strings, and all string literals are implemented as an instance of this class. Strings are constant, their value cannot be changed after they are created. String buffer support mutable strings. So if you want to change the value of the string, you should use string buffers instead of string class. Because string objects are immutable, they can be shared. So you have char at length format, substring contains, join equals, is empty, etc. And we talk about the string builder class. String builder in Java is a class used to create mutable, or in other words, a modifiable succession of characters. So a string class is basically representing character strings and it's immutable. And a string builder class is used to create mutable or modifiable succession of characters. Like string buffer, string builder class is an alternative to Java string class. So if you want it to be mutable, you use either string buffer or string builder class, as the string class provides an immutable succession of characters. However, there is one significant difference between string buffer and string builder, that it is the latter, which means it's the string builder class that is non-synchronized. So string buffer is synchronized and string builder is non-synchronized. It means that string builder in Java is more suited choice while working with a single thread, as it will be quicker than the string buffer. There are multiple methods available like append, insert, replace, delete, capacity, ensure capacity, etc. String buffer class is used to create mutable, modifiable strings. So we studied about the string class, which represents character strings, and it's immutable. It's immutable. If you want your string to be mutable, you can either use string builder class or you can use string buffer class. Difference between string builder and string buffer is that string builder is non-synchronized, so you can use it with the single threaded, and string buffer is synchronized, so you can use it with multi-threaded. So string buffer class is used to create mutable modifiable string. So two class which you can use for modification of the strings is string buffer and string builder. String class cannot be used for modifying the strings. String buffer class in Java is the same as string class except it's mutable. So it represents character strings. You can use append, insert, replace, delete, reverse, capacity, etc. String class versus string buffer class. So we already established
that they both are the same, except the string class is immutable and string buffer class is mutable. You can transfer the string class to another, and string buffer class will be synchronized, so you can use it with this multi-threaded. String is slow and consumes more memory when we concatenate too many strings, because every time it creates a new instance. String buffer is fast, consumes less memory when we concatenate strings. So string class is consuming more memory and it's slow. String buffer is fast during the concatenation of the new string. And the reason why string class is slow is because every time it creates a new instance. String class overrides equals method of the object class. So you can compare the contents of two strings using the equal method. String buffer class doesn't override the equals method of the class. String class is slower while performing concatenation operation. I don't know why they're saying it twice. It's the same thing, concatenation. String class uses string constant pool. String buffer uses heap memory. Okay, so recap once again. String class is immutable. String buffer class or string builder class, they are mutable. String is slow, consumes more memory. String buffer is fast, consumes less memory. And the reason for that is because string class creates a new instance every time um, when we concatenate too many strings, while string buffer doesn't do that. Then string class uses string constant pool and string buffer uses heap memory. String class overrides the equals method, so you can use it to compare the contents of the two strings. String buffer class doesn't override the equal method of the object class. Okay, then we talk about IO streams. Java input output is used to process the input and produce the output. So Java input output stream is used to process the input and produce the output. Java uses the concept of a stream to make IO operation fast. Java uses the concept of a stream to make the IO operation fast. It processes the input and produces the output, and it uses concept of a stream. The java.io package contains all the classes required for input and output operations. So if you need to perform input output operation, you need to use the java.io package. We can perform file handling in Java by Java IO API. Java file class is an abstract representation of a file and directory path name. So file class is a representation of file and directory path name, and it's abstracting, which means only representing the essential information about the file and the path name. The path name can be either absolute or relative. Absolute means full path, relative means in relation to a particular directory. File class have several methods of working with directories and files, such as creating new directories or files, deleting and renaming directories or files, listing contents of directory, etc. So file class is an abstract representation of a file and directory path name, and it has several methods for working with directories and files. The different methods like create temp, create new, can write, can execute, can read, is absolute, etc. Then we have the auto closable, closable, and flushable interfaces. There are three interfaces that are quite important to the stream classes. Two are closable and flushable. They are in java.io and they were added by JDK5. Okay. So there are three interfaces that are important in stream classes. Two are closable and flushable, and third one is auto closable. Closable and flushable are defined in java.io, and auto closable are defined in java.lang. Autoclosable provides support for try with resource statement, which automates the process of closing a resource. Only objects of classes that implement autoclosable can be managed by try with resource. It defines only the close method. So autoclosable provides support for the try with resource statements, which automates process of closing a resource. Objects of a class that implements closable can be closed. Closable extends autoclosable. Therefore, any class that implements closable also implements autoclosable. It also defines close. Objects of a class that implements flushable can force buffered output to be written to the stream to which the object is attached. It defines flush method. Java IO exception. So exceptions means any input output exception that can occur while reading a file or writing a file, basically accessing the file system. So any input output exception that occurs while reading or writing a file is the IO exception. Java IO exception extends Java exception class. So to get the serializable form, the interface serializable is implemented by the class that extends IO exception. This is useful when you have custom exception classes for your project. For the program to exit gracefully in an exception case, we should surround it using try or catch block. This also means IO exception is a checked exception. Example is try. We create a object called FIS using the class by instantiating the class file input stream, passing the file path, and then catching the exception inside the catch method, and we print the message of whatever exception is outputted. So IO exception means any input exception that occurs while reading a file or writing to a file. Okay, byte stream classes. Byte stream is defined by two abstract classes at the top of the hierarchy. They are input stream and output stream. These two abstract classes have several concrete classes that handle various devices, just disk files, network connection, etc. Some byte stream classes are buffered input stream, buffered output stream, data input stream, data output stream. These classes define several key methods, and two most important are read and write. Read reads the byte of the data, and write writes the byte of the data. So byte stream is defined by using two abstract classes, abstract class at the top of the hierarchy, that is input stream and output stream. I have several concrete classes that handle various devices such as disk and network connection. Okay. Okay, so byte stream is defined by using two abstract classes, input stream and output stream. These classes have several concrete classes to handle various devices, just disk files and network connection. They have defined several key methods like read and write for reading and writing the byte of the data. Character stream classes. Character stream is also defined using two abstract classes at the top of the hierarchy. They are reader and writer. Two abstract classes have several concrete classes that handle Unicode character. So byte stream handles devices such as disk files and network connection, and character stream classes handle the Unicode character. Some character streams are buffer reader, buffer writer, file reader, file writer. Read method is used with buffer reader to object to read characters, as this function returns integer type value, has what we need to use a typecasting to convert into a char type. So let's just fix this. Defined by using two abstract classes, reader and writer. Have several concrete classes handle Unicode character. Okay, read method is used with buffer object to read characters. As this function returns an integer type value, it has what we need. Use typecasting to convert into character type. This function returns integer type value. It has what we need to use typecasting to convert into char type. Okay. So again, because these two questions are important, let's do a recap one more time. Byte stream classes defined by using two abstract classes, input stream and output stream. Character stream classes are defined by two abstract classes, reader and writer. So this one is input and output stream classes, and this is reader and writer. Byte stream classes have concrete classes to handle various devices such as disk file and network connection. Character stream classes also have concrete classes to handle Unicode character. So these classes handle Unicode character, and byte stream classes handle different devices. This is two most important methods: read and write. To read and write the byte of the data. Character stream classes has read method to read characters. Now, a program to save the data in a file. So we'll use the java.io package, and we're going to import the classes such as buffered input stream, buffered output stream, file output stream, IO exception, and then let me just make this a little bit big. Okay, we have a buffered input stream example class. Inside of the main function, we create an object called input stream. We instantiate a class called buffered input stream, pass system.in. Then we create an object called bytes, which will be an array by instantiating byte. And then we take the data from the user using this object and accessing the read method of this class and passing on to the byte. So when the user, this basically takes the input from the user, and this function is going to read whatever user has written in the from the keyboard, and it's going to store it inside of bytes. The bytes is a variable. And then for the output into a file, we'll instantiate file output stream. So for input, we used buffered input stream. And for output, we'll use file output stream. And we remember that buffered input stream allows us to mutate any object of string. So we can always mutate it also. So we create a variable called out. And then we also go ahead and instantiate buffered output stream. And we create a variable called output stream. We access the method. The reason why we're instantiating it is because we need to access its method called write. And the job of this is to basically write whatever user has entered. So because you want to write it on file, we're using file output stream, and we're going to pass this object over here in the buffered output stream. And then finally, whatever user has entered, we're going to write that on the file. and this object will have access to the all the information about this particular file, like the path, directory address, content, etc. And then finally we just flush it and just let the user know that the data has been saved into the file. Okay, then we do object serialization. We discussed this yesterday. So object serialization allows us to convert an object into a byte stream, and then that can be read or written on a file, and this process is called serialization. And you can also deserialize, which means convert the byte stream back into the object. So object serialization mechanism to convert the state of an object into a byte stream. In object serialization, an object can be represented as a sequence of bytes that includes the object's data as well as information about the object's type. So this byte that we have, this byte stream, includes not only the object's data but also the information about its type and the type of the data that's stored inside of the object. After serialized object has been written into a file, it can be read from a file and deserialized also. That is, the type of information and byte that represents the object and its data can be used to recreate the object in memory. How does object serialization work in Java? So an object is eligible for serialization if and only if its class or its parent's class implements either the java.io.serializable or java.io.externalizable interface. In serialization process, we convert an object state into a byte stream so that it can be transferred from one JVM to another and divert the byte stream back to the original object. Serializable is a interface, so this interface, which contains no methods, and it tells JVM that the object of this class is ready for being written to or read from a persistent storage like a file or over the network. By default, JVM takes care of writing and reading the serializable object. The serialization or deserialization are via following two methods. One is object output stream dot write object that writes the serializable object to the output stream, and second is object input stream dot read object that reads the constructs and returns an object from the input stream. Okay, let's do one more time. So what is an object serialization? Object serialization is a mechanism of converting the state of an object into byte stream. And in object serialization, object can be represented as a sequence of bytes that includes the object's data and the information about its type and the type of the data that's stored onto the object. After it's serialized, it can be after the object is serialized, it's been written to the file. It can be read from the file and deserialized also and convert back into the object. The type of the information and bytes that represent the object its data can be used to recreate the object in the memory. How does the object serialization work? For any object to be eligible for serialization, it must its class or its parent class must implement the java.io.serializable or java.io.externalizable interface. In the serialization process, we convert a state of an object into a byte stream so that it can be transferred from one JVM to another JVM and divert back into the same object. Serializable is a marker interface, contains no methods, that tells JVM that object of this class is ready for being written to and read from a persistent storage or over the network. So we're talking about serializable, which is a marker interface. It tells JVM that your object is ready for it to be read or written uh, from a persistent storage like a file or over the network. By default, JVM takes care of writing and reading this object. The serialization deserialization are done via following two methods: object output stream dot write object, which writes a serializable object to an output stream, and object input stream dot read object that reads the constructs and returns the object from the input stream. What is the use of object serialization in Java? First is communication. If you have two machines that are running on the same code, that are running the same code and they need to communicate, an easy way is for one machine to build the object with the information they would like to transmit and then serialize the object to another machine. So first is communication. If two machines are running the same code and if they want to communicate with each other, uh, one machine can build the object by serializing it into a byte stream and then serialize the object to another machine. Then second is persistence. If you want to store the state of a particular operation in a database, it can be easily serialized into a byte array or a byte stream and stored into the database for later retrieval. So first is communication. If two machines wants to communicate, one machine can convert it into a byte stream or and then serialize that object into another machine. Second is persistence, which means that if data needs to be stored permanently, it can be converted into a byte stream array and then stored into the database for a later retrieval. Then deep copy, if you need an exact replica of an object, you don't want to go through the trouble of writing your own specialized clone class. Simply serializing the object to a byte array and then deserializing it to another object achieves this goal. So if you want to do a deep copy, you want to copy an object and you don't want to use the clone class, then you can just serialize the object to a byte array, and when you want to convert it back to the object, just deserialize it. Caching. Sometimes an object takes 10 minutes to build, but would only take 10 seconds to deserialize. So rather than holding on to the giant object in the memory, just cache it out to a file via serialization and read it later when it's needed. Cross JVM synchronization. Serialization works across different Java virtual machine and they may be running on different architectures. And saving the program states on disk. Example, storing state of a game. Sending data over network in form of object. For example, sending messages as objects in chat applications. So what are the uses of object serialization? First is communication. If there are two machines which want to communicate with each other, the best way is that one machine converts it into a serializable byte array and then run it onto another machine. Then you have persistence. If you want to store it into a database, you can convert it into a byte array and then store it into a database for later retrieval. Deep copy, if you want to copy an object rather than using a clone method of a class, you can serialize into an object, serialize the object into byte array, and then deserializes to convert it back into the object. Then you have caching. Sometimes it takes 10 minutes for an object to get serialized, but only 10 seconds to deserialize. So rather than holding onto the object in the memory, just cache it. Then cross JVM synchronization. So this serialization works across multiple JVMs on different machines. And you can also save the program state on a disk using this object serialization, like storing a state of a game. And then you can also send messages as objects in chat applications. Java API. Java API is a group of pre-written packages, classes, interfaces, along with their methods and attributes. The collection API in Java is used for storing and manipulating the group of objects. Collection framework is a group of classes and interfaces to store and manipulate the group of objects. So the main thing, the key thing in to remember in the collection framework, collection API is basically it is used to store and manipulate group of objects. Various operations like searching, sorting, insertion, deletion can be performed on these objects. Various classes just array list, vector, stack, hash set, are provided by this collection framework. Also, there are many interfaces such as list, queue, set that are available in collection framework. You have date and time class. You can instantiate it, convert uh, one date into another date, retrieve current date, compare two dates. There are a lot of methods available. So Java supports creating and modifying date and time using primarily two packages, java.time, java.util. The package java.time was a part of Java 8 release that introduced the new immutable class, solving the shortcomings of the legacy java.util.date and java.util.calendar classes. So earlier we had java.util.date and calendar available, but later on after Java 8 was released, there were some issues with that, which got solved by introducing a package called java.time. Okay, the different methods like date. Uh, you have constructor, which is date. You can instantiate it to create a date object. And then there are methods like before, after, clone, compare to, equals, etc. This is an example of date time program. Import java.util.date. Create a date object by instantiating the date class. Print the date. Get the time. Again, instantiate another date, but this time with your own time in milliseconds. Store that into another variable. Compare the two dates, the current and the one you created. If the result is 0, both dates are the same. The result is 1. The first one is later than the second one, and otherwise, the first one is earlier than the second one. Talk about set interface. Set is a group of dissimilar objects. Java provides set as an interface that extends the collection interface, and hence it has access to all the methods inherited from a collection interface. Unlike list interface, sets cannot contain duplicate elements. So set is a group of dissimilar objects. It extends the collection interface, so it has all the access to its methods. It cannot have duplicate elements. Some of the common methods are add all, iterator. These classes are defined in collection framework and implement the set interface, which is hash set, linked hash set, enum set, and tree set. So this is our set interface, and it implements. These are the classes defined inside of that: enum set, hash set, link set, and tree set. Iterator in Java collection framework. In order to pass the elements of any collection, we make use of iterable interface, which is the root interface of the whole collection network framework. The iterable interface extended by collection interface, hence all the interfaces and classes of collection framework implements this interface. Most important feature of iterable interface is to offer an iterator for the collections. Only one method, which is abstract, whose name is iterator, is contained in this interface. It returns an object of type iterator. Hashtag class. Java.util.hashtag class is a member of Java collection framework, which implements set interface. Its purpose is to create collection and store it in a hash table. Each element in a set has a unique value of its own called hash code, which is used as an index in which elements associated with the hash code is stored. Hash code is obtained by converting informational content into a unique value known as a hash code. Hashing ensures the execution time remains constant even for set bigger size. The elements are inserted in hash set irrespective of the order of insertion, and the order depends on the hash code of the elements. So hash set class is a member of Java collection framework used to create collection and store it in a hash table. Each element has unique value obtained by converting informational hash code is obtained by converting informational content into unique value. Execution time remains constant. Order doesn't matter, so elements are inserted irrespective of their order of insertion. Difference between hash set and tree set. Hash set doesn't maintain any sequence of the elements to be added. Tree set maintains the order of the element. Hash set implemented by hash table. Tree set is implemented by tree structure. Hash set performance is better. Tree set performance not as good as hash set. Hash set is backed by hash map. Tree set is backed by tree map. Okay, Sumaya,
Yeah.
can you read this?
The map interface.
Yeah.
The map interface of the Java Collections framework provides the functionality of the map data structure. Elements of map are stored in key value pairs. Keys are unique values associated with individual values. A map cannot contain duplicate keys, and each key is associated with a single value. We can access and modify values using the keys associated with them. A map is suitable if we have to search, update, or delete elements on the basis of a key. In the diagram, we have values United States, Brazil, and Spain, and we have corresponding keys US, PR, and ES. We can access those values using their corresponding keys.
Right. So I think we did this yesterday, and it's self-explanatory.
Yeah,
So basically, map interface provides functionality of a map data structure, and the data is stored in key value pairs. If you want to access the data, you can use the keys, and it's supposed to store a single value. One second, let me just add the animation. The assignment for the Java is like too much, isn't it?
yeah,
A lot of questions. So that's why I think during the last few days remaining from the in the last week, maybe what we can do is we can do two classes, one for whatever that subject is coming in, and second for the next subject coming in, like the and then we only cover the important questions, and we just do the recap. All the study should happen only before the last week. Last week, in my opinion, should just be for just making sure if we know 10 things, then we should know them properly.
yeah. First exam is DBMS, right?
I don't remember actually. Do you remember what it is?
I think it's DBMS.
Okay. Okay. I haven't studied the what is that data map structure or something. No, algorithm. This subject where you have algorithm and stuff, right?
Yeah, that one is last.
Yeah. You sure that's last, right?
I need to check again, but I think first DBMS and then Java and then data structures and algorithms.
Okay. I've reached till here. I have to finish all of these guys by tomorrow anyhow. I was stuck into this because you have to go through watching YouTube videos a lot to understand these. So I have to finish these guys by tomorrow anyhow, because then I need some time to study data structures and algorithm also.
Yeah,
Okay, let's continue. I'm not too much worried about Java because I think Java we have covered good and it's not too much left. So
yeah.
yeah, I think Java should be good, and mainly they are theory only, so it's fine. Okay.
Classes that implement map. Since map is an interface, we cannot create objects from it.
Okay.
In order to use functionalities of the map interface, we can use these classes. Hash map, enum map, linked hash map, weak hash map, and tree map.
Okay, so we remember as per the definition of an interface, that an interface cannot be instantiated. It can only be implemented or implemented by a class, or extended by another interface. So it cannot be instantiated. So I think that's what he's talking about. I think map is an interface. We cannot create objects from it. Okay.
Interfaces that extend map, sorted map, navigable map, concurrent map.
Okay. Okay.
The hashmap class of the Java collections framework provides the functionality of the hash table data structure. It stores elements in key value pairs. Here, keys are unique identifiers used to associate each value on a map. The hashmap class implements the map interface. It is non-synchronized. The advantage of hash table is that the time for basic operations like get and put remains constant irrespective of the size of the map.
Okay, so let's take an example of creating a hash map in Java. It resides inside of the java.util package. So to create a hash map, we say hash map and then the type string integer, uh, and then the name of the variable languages equals new, instantiate that, and then add the elements to the map using the put method. So it takes two parameters. Okay, so we're passing all those two parameters. I think it takes key value pair, I believe, store elements in key value pairs. Yeah, and then print it the languages. So now you can see that it's printing those in key value pairs. Key is Java, like this, the first one, and the value is 8. Similarly, JavaScript 1, Python 3. Okay, so in the above example, we have created hash map named languages. Uh, we have used put method to add elements. Okay, so put method is used to add the elements in the hash map, and to create the hash map, you this is the syntax, new hash map, and this angle brackets. So hash map is class of a Java, provides functionality of hash table data structure, stores elements in key value pair. These are your key value pairs. Keys are unique identifiers used to associate each value on the map. So these are unique identifiers, Java, JavaScript, and Python. It implements the map interface. Non-synchronized advantage is that for basic operations like get and put remains constant irrespective of the size of the map. Okay. So see in the assignment they're not asking the questions directly. Sometimes they're just asking a little bit different, like advantages of this. But if you don't know what that thing is, then it's a little bit difficult to just learn or just remember the advantages. So that's why this presentations cover everything. Like I think I've covered more than 95% of the topics that are there in the uh, textbook. Oh, why do we not have animation on this? Okay, go on.
Use of map and hash map. Use of map. Maps are perfect to use for key value association mapping such as dictionaries. It is used when we need fast lookups. The maps are used to perform lookups by keys or when someone wants to retrieve and update elements by keys. For example, a map of zip codes and cities, errors and their descriptions, etc.
So
You,
we can think of those like dictionaries. If you want to look up any word and meaning, We can go and look at by the letter M, for example, the word starts from M. So it's just like dictionaries. You have key value pair association. It allows us to do fast lookup. We can directly go there and get the data in the database using that key, and that's what it's talking about here. Okay.
Use of hash map. The hashmap class of the Java Collections framework provides the functionality of the hash table data structure. It stores elements in key value pairs. Here, keys are unique identifiers used to associate each value on a map. The hashmap class implements the map interface. It is non-synchronized. The advantage of hash table is that the time for basic operations like get and put remains constant irrespective of the size of the map.
It's the same thing that we learned earlier. Just kind of copy pasted it here because they're asking give us information about map and hash map in the assignment. I put these things together, but it's the same presentation in previous one for the hash map. Let's just quickly underline these to make it readable. Perfect to use for key value association mapping. Fast lookup. For recap, it just becomes easier if we have some underlines. Maps are used to perform lookups by keys when someone wants to retrieve lookup by keys to retrieve and update elements. Okay, provides functionality of hash table data structure. Stores elements in key value pair. Keys are unique identifiers. Implements map interface. Non-synchronized advantage is that the time for basic operations remains constant. Okay, that's easy to read. So we'll do a recap since an important question. So what's the use of map? Perfect to use for key value association, for fast lookup, perform lookup by keys to retrieve and update elements. Hash map provides functionality of a hash table data structure, stores the elements in key value pairs. Keys are unique identifiers. It implements map interface. Hash map is non-synchronized. And the advantage of the hash table is that the time for the basic operation, like get and put, remains constant, even though the size of the map is large or small. Okay, difference between hash set and hash map. Go on.
Set interface is implemented by hash set. Map interface is implemented by the hash map. It contains hash set contains only values. Hash map contains a mapping between a key and its value. Hash set can be traversed. Hash map needs to be converted into a set to be iterated. A hash set cannot have any duplicate value. Hash map can have duplicate values with unique keys. Hash set can hold just one null value. Hash map can contain a single null key with a number of null values.
One second. Need to fix this. Okay. Okay, go on.
Difference between set and map interfaces. Set contains only the values, whereas map contains key and values. Set has unique values, whereas map can contain unique keys with duplicate values. Keys are
Hmm.
unique, but two or more keys can have the same value. Set can include just one null, whereas map can include a single null key with a number of null values.
It's the same thing whether they ask hash set and hash map or set and map. It's the same uh, difference. Okay. Let's go to the list interface now. So, did we study hash set? Let me see. What all did we study? Mm, Okay, we studied hash set actually. Correction of the hash table. Okay. And then we studied hash set and tree set. Then map interface. Then hash map class. Then we found the difference between the hash set and hash map. Okay, fine. Go on.
List interface extends the collection interface and hence it comprises all the methods available in the collection interface. It is used to manage the ordered collection of objects. List preserves the insertion order and allows duplicate values to be stored. Elements can be accessed by referring to their position in the list with zero-based index. This interface comprises different methods that enable easy manipulation of elements based on the element index. Various methods defined by list interface are add all, get, index of, iterator. The list interface is implemented by vector, ArrayList, and linked list classes.
Okay, so list interface extends collection interface, comprises all the methods in the collection. Let's make it readable while we are recapping this. So extends collection interface, manages ordered collection of objects, preserves insertion order, allows duplicates. Elements can be accessed by referring to their position in the list, accessed by referring to the position with zero-based index. Interface comprises different methods enable easy manipulation of elements. Various methods defined by lists add all of those. Okay, let's just recap quickly. So it extends collection interface. Obviously, it'll have all the methods that collection interface has. It is the main thing you need to remember. It is used to manage the ordered collection of object. So lists are basically ordered collection of elements. So that's why it's used to manage the ordered collection of objects. Preserves the insertion order. In the way we inserted it, preserves that order, that sequence. And it does allows duplicates. Elements can be accessed by referring to their position. So it is index based 0, 1, 2. So with index we can access the elements by their index. It has different methods to manipulate the elements basis their index. We can find the elements by its index and then change it. Different methods are add all, get, index of. Index of will get you the position of that particular element. And then you have the iterator. The iterator will allow you to loop through all the elements because it's index based, like we had in Python. The list is implemented by vector, array list, and linked list classes. So three classes that implement the list are these. I don't know why only one is bold. All three should be bold. I think it's clear. One vector class. Go on.
The vector class extends abstract list class.
Okay.
The list interface is implemented by this class. An index is used to access the elements of a vector. Vector is just like a dynamic array. There is no specific size of a vector. It can shrink or grow automatically whenever required. The elements of a vector can be retrieved with an integer index. Vector is quite like array list, but it is synchronized. That is, it is thread safe. The vector class should be used in the thread safe implementation only, and if you don't require synchronous access, then array list should be used as it will perform better.
Okay, I think this is something we are repeating time and again, that if you want single threaded, then use the non-synchronous classes or interfaces. If you want multi-threaded, then use the synchronous one. So this is another example of where they are iterating the same thing again. They're saying that if you don't require the synchronous access, then use the array list, because array list is non-synchronized. But uh, yeah, but vector is actually synchronized. So that's why it's good for multi-thread. So because it extends abstract list class, which actually in turn the list class, interface. That is why whatever we discussed about the list interface, it's same as the true for a vector also, except a few. So a list interface is basically allowing you to access the elements by the index. Same is the true for vector class also. But a few things which are different is it's like a dynamic array. It's just like a dynamic array. So no specific size of a vector. It can shrink or grow automatically when required. So when we learned about dynamic array, we know that dynamic arrays can shrink or grow automatically. Okay, retrieve by the index. We don't need to highlight this. We already know this. Quite alike array list, but it is synchronized. So this is something we need to remember, that it's synchronized. You can use it for multi-threading. That's all we don't have to remember. It's fine. Okay, moving on. Go on.
The stack is a linear data structure that extends the vector class. It is based on last in first out. The elements are added as well as removed from the retrieved end. That is where the latest element was inserted or removed from. Stack class models and implements a stack data structure. In addition to the basic push and pop operations, the class provides three more functions of empty, search, and peek. The class can also be referred to as the subclass of vector.
Okay, so this is what we have been studying. If you remember from whatever we have discussed today, iterable is always the top, and then we have the collection framework. So collection extends iterable. Then we are now studying about the list interface. List extends collection. Okay, and then we know that an interface can be extended by another interface. That's why this whole group you're saying is our interfaces, right? So one interface can extend another interface, but classes will implement it. They will not extend it. So they cannot extend the interface. They will implement it. That's why it's implementing here. Okay, so vector class is implementing the list interface. So we studied about the vector class in the previous slide, and stack is extending vector. So it's inheriting. Here inheritance is happening because these both are classes. So one class can extend another class. So we're talking about the stack class now. So stack class extends the vector class. So this is the hierarchy that they're showing, that this is the order in which it is extended or implemented. So stack is a linear data structure that extends various vector class. We already spoke about it. Main thing we have to remember is the linear data structure. I just make that bold. A linear data structure. It's based on last in, first out. Element which was last inserted in, will come out first. Elements are added as well as removed from the rear end. So elements are added or removed from the rear end. That is where the latest item was inserted or removed from. Stack class models implements a stack data structure. In addition to basic push and pop operations, class provides three more functions. Push basically pushes the item in the array. Pop removes the item from the array. So these are basic operations. And then it has more functions like empty, search, peek. It's also called as subclass of vector. Why? Because it's a child class of vector. It is extending it, there's inheritance. That's why it's called a subclass, and this is superclass. So Maya, do you have the energy or should I read?
I can read.
Okay. We'll finish it at 7:30. I'm trying to spend more time because we don't have much time left in the examination.
Okay.
What?
Similarities and differences between list and set. The list and set both extend the collection interface. However, there are some differences between the both, as mentioned below. Duplicate elements are allowed in list. Only unique elements are allowed in set. List is an ordered collection that maintains the order of insertion of elements. Set is an unordered collection that does not preserve the order of insertion. The list interface can allow any number of null values. The set interface allows just a single null value.
When we were doing Python, we learned about list and set, and we learned that set all will always contain the unique element, and it doesn't really care about the order. But list, duplicate elements are allowed, but it has to be ordered. Okay, and the last one is last difference is that list can allow any number of null values, and set will only allow one null value. Okay, now we on to another topic called graphical user interface and Java database connectivity. Go on.
Graphical user interface in Java.
1 second, yeah.
Graphical
Give
u-
me just 1 second. I'll fix it. It's added 3 times. My God. Yeah. Okay.
Graphical user interface is a kind of interface through which users can interact with computer applications,
Yeah.
be it web applications, mobile apps, or other commonly used applications like online banking or the online railway reservation system. We look for ease of interaction by using proper buttons, menus, and other controls. These interfaces use proper GUI components and controls. Earlier, engineers or programmers used to interact with the computer through the DOS prompt interface using command line. This interface is also used to be called as the character user interface, which was very inconvenient for non-programming users. With the development of the graphical user interface, the use of computing devices by non technical users or ordinary users has been more convenient because GUI provides an interface that allows users to interact with electronic devices through graphical objects and controls to convey information and represent action taken by the users.
Right. So it's just talking about the UI part. Like even if you open a mobile app, it has different settings. You can create your profile. You can edit your profile, update your profile. So user is able to send a request for CRUD, which is create, read, update, and delete through that interface, and that is basically what the graphical interface is. An interface that allows the user to interact with the computer application. Like for example, right now I'm looking at a GI. I can click this button, I can make it small, I can save it. So this is my graphical interface. So that's what it's talking about.
Java
What?
provides three main sets of Java APIs for graphical user interface programming languages: AWT Abstract Window Toolkit, Swing, JavaFX. AWT is an API to develop graphical user interface or Windows-based applications in Java.
Okay.
Java AWT components are platform dependent, that is, components are displayed according to the view of operating system. AWT is heavyweight, that is, its components are using the resources of underlying operating system. The java.awt package provides classes for AWT API such as text field, label, text area, radio button, checkbox, choice list, etc.
So when you're going to develop, of course, Java is used for developing the mobile application, a mobile app. Now, mobile app has a different UI. Like click on the settings. Like even take example of WhatsApp. So on WhatsApp, you can set your profile. You can change your status. So what is all that? That's all your graphical user interface for the user. Now, how do you think these things are created? How a button is created where a user can click and change their status? So these are created with the help of these tools. We need an API through which we can build this entire interface. So for building, Java is providing different types of APIs. One is AWT, Swing, and JavaFX. Now we are talking about AWT. So this AWT has a package, basically is a package java.awt, and it has got different classes available. For example, text field, if he wants to write something on the text, like an input field, you can think of like uh, he's filling up a form, for example, on an application. There's a banking app and he's filling up a form. So we need an input. So for input, you don't have those HTML elements available, like you can't use input. So you have to use the Java related classes for that. So text field is going to be your input, your label, whatever you're going to write. So just above the input you have the name written. So name will go inside the label. Then you have the text area. So in case if he needs to write not just one sentence but more content, you will use text area because that will give you a bigger text field. Then you have radio buttons. So like you have those circles like check. Click on that, there's a dot, click on yes or no, so that's your radio button. Similarly, you have checkbox, you have choice, you have list. This is for basically when you want to fill up a form or anything. So these classes are available for that, when for building your mobile graphical user interface for the users to interact with it. Okay, go on. Then you have Swing.
Swing is a part of Java Foundation class that is used to create window-based applications. It is built on the top of AWT API and entirely written in Java. Unlike AWT, Java Swing provides platform-independent and lightweight components. The javax.swing package provides classes for Java Swing API such as JButton, JText field, JText area, JRadio button, JCheckbox, JMenu, JColor chooser, etc.
Okay. Okay. So, like you have the AWT, similarly you have the swing. But one of the key differences between AWT and swing is that uh, swing swing is basically platform independent, which means its UI is not going to be according to which system, which operating system you're using. You're going to see the same UI for development in all the platforms. But in AWT, it changes basis on what operating system you're using it. Okay, and again, like you had text field, over here you can see these things are prefixed with J. So text area becomes J text area, text field becomes J text field. If we had button in AWT, this becomes J button. So just a slight difference. You can use either Swing, you can use AWT, or you can use JavaFX. I'm not 100% sure, but probably JavaFX is the most popular. Yeah, so you can use any of these development tools, development APIs to build your application with Java. Did we not cover JavaFX? Are we going to cover later? Yeah, we're going to cover later. That's fine. Let's read the differences.
A difference between AWT and Swing. AWT components are platform dependent. Java Swing components are platform independent. AWT components are heavyweight. Swing components are lightweight. AWT doesn't support pluggable look and feel. Swing supports pluggable look and feel. AWT provides less components than Swing. Swing provides more powerful components such as tables, lists, scroll panes, color chooser, tabbed pane, etc. AWT doesn't follow MVC, model view controller, where model represents data, view represents presentation, and controller acts as an interface between model and view. Swing follows MVC.
Right. Before I forget, so Maya, can you do one thing? You have access to this particular um, Google slides, right?
Yeah,
When you have some time, I know I have already marked the ones which are there in the assignment as star. At that point, I didn't have the question paper. So can you go through the entire question paper and whatever topics are important, which have been asked in the question paper, you can just star it over here on those slides. And if the heading is not same or slightly different than what's been asked in the question paper, maybe you can add that question over here. Okay.
okay, I'll do that. Do I have editing access?
I think you have. Let me see. No, let me give you that. Okay, so now you have the editing access. Cool, let's continue. So now we talk about the Java FX, and I think it's one of the most popular. Let's see, we'll find out.
Java FX is a Java library used to develop desktop applications as well as rich internet applications. The applications built in Java FX can run on multiple platforms including web, mobile, and desktop.
Okay, so if we build something in Java FX, we can run the same application on desktop, mobile, or web.
Java FX is intended to replace Swing in Java applications as a GUI framework.
Yeah, that's what I was saying. I think it's the most popular. That's why it's replacing Swing. Swing is anyways good, and we are getting something better than that, which is Java FX.
However, it provides more functionalities than Swing. Like Swing, Java FX also provides its own components and doesn't depend upon the operating system. It is lightweight and hardware accelerated.
Okay, so looks like Java FX and Swing have very common features, such as both are platform independent, both are lightweight, both have different components. But I think Java FX is providing more functionalities compared to the Swing.
It supports various operating systems, including Windows, Linux, and macOS. Web pages can be embedded with JavaFX applications. JavaFX contains built-in components which are not dependent on operating system. JavaFX code can be embedded with the CSS to improve the style of the application. JavaFX application structure contains three components. A stage embraces all the objects of JavaFX application and it is represented by the stage class of JavaFX.stage package. The show can be used to display the content of the stage. It acts like a container for all the JavaFX objects.
Right. So now we are coming to like real development. All this why we have been just learning the theory, but now they are discussing about what are the APIs you can actually use to build the real time application. So we are discussing Java FX in detail now and how an application is built. What's the structure of an application? You're taking a look at it. You have the stage, which is the one that wraps everything. You have the scene, then you have the scene graph, and how in HTML you have different nodes like head, body, and all the HTML elements. Similarly, you have the nodes here. So you have root node, you have branch node, leaf node, all of that. So this is your application structure. Go on.
A scene graph is a data structure that is a collection of nodes and is represented by a JavaFX.scene package. Scene actually holds all the physical contents or nodes of a JavaFX application. Creating scene is necessary in order to visualize the contents on the stage. A node is a basic graphical object such as UI control objects. A
Mhm.
button, a checkbox, 2D, 3D geometric objects like circle or triangle.
Yeah. Think of it like a drama. In drama, you have a stage. Without stage, nothing can happen. People will perform at a stage. So you need to set the stage first, okay? Which kind of wraps everything. Then the scene. What will be the scene? So scene will be the view part, which the audience will view. So that's your scene. And node is the actual objects, like the people who are performing the drama. So the actual objects, like your buttons and all of those check boxes, which is going to be visible on that scene. So you may have an empty scene, like you won't have anything to, unless you have the nodes, unless you have the people. So do you think of the like people who are button check boxes that user can view. So you have a stage, you have a scene, and then inside of that you have these elements like button, triangle, all of these, which are called nodes uh, for the user to interact with. Okay, so this has been asked in the assignment. Let's move on.
User interface components of JavaFX. The GUI of every desktop application mainly considers UI elements. The UI elements are the ones which are actually shown to the user for interaction or information exchange. Layout defines the organization of the UI elements on the screen. Behavior is the reaction of the UI element when some event is occurred on it. The package javafx.scene.control provides all the necessary classes for the UI components like button, label, etc. Every class represents a specific UI control and defines some methods for their styling. You will
Right.
see these UI
In the next.
components.
Yeah. So we're talking about user interface components, UI interface. Full form is user interface components. So what are the user interface components? Of course, your buttons, check boxes, which the user can actually use and interact with. Now, your UI components are starting from here. This is just giving you a background before we actually start talking about. So I think in the examination, you don't have to write this. This is just to give you a background. So uh, Every application will consider UI elements, layout, and behavior. So UI elements which are shown to the user, which is what they are asking. Tell me about the UI components. Layout defines the organization, how like it has a header, footer, body. So that's the layout. Okay, how they are laid out onto the screen. Behavior is like when the user clicks on the button, what happens? If he submits a form, then the form should be submitted, next page should be visible. So that's a behavior, that's a reaction, or some animation should happen. So that's a behavior. So when the user interacts with that element, what happens next? What's the event that get fired? Okay, so these UI components which they are asking for is inside of this package, Java fx.scene.control. So when you're going to use those buttons and labels, you're going to import Java fx.scene.control, and then you'll probably instantiate this class and use this buttons and label. Every class represents a specific UI control that defines some methods of their styling. You'll see in the next slide. Okay. I think you can give a little bit of information about the UI elements, some content before you actually start describing these. So you have label. Label is a component that is used to define simple text on the screen. I think if you just, it should be very easy to remember and easy to explain, but I'll still read it once. Button is a component that controls the function of the application used to create a labeled button. Button class is used. So there's a class called button class. Radio button is used to provide various options to the user. The user can only choose one option among all. A radio button is either selected or deselected. Checkbox is used to get the information from the user which contains various choices. User marked the checkbox either true or false. Text field is used to get the input from the user in the form of text. So see, inside of control, there's another class called text field. So I think text field must be inheriting control. Similarly, for radio button, you must be having control dot radio button. For label, you will have control dot label. That's how it will be available. Okay, password field is used to get the user's password. Hyperlink is used to get refer to any page of the application. Slider is used to provide pane of options in a graphical form where user needs to move the slider over the range of values. Progress bar is used to show the work progress to the user. If he's filling up multiple pages of a form, then the progress bar will keep on filling as he completes first, second, and the third page. Progress bar indicator, instead of showing analog progress bar, it shows the digital progress bar. So this is your analog, this is digital, like in numbers, like 20%, 30%. Scroll bar is used to provide for scroll bar to the user so that user can scroll down the application pages. Menu provides the menu class to implement menus. So in the header, like in your WhatsApp, you have a header and then you have the menu. You click on that icon, then you'll get list of menus. Like click go on account, go on settings. So that's your menu. Tooltip is used to provide hint to the user about any components. Mainly used to provide hints about the text fields. So sometimes the buttons and the text fields are not like you don't know what to do with them. So then you have the icon, you hover on it or you click on it, you come to know what does that button do or what is the user expected to do when you hover on the tooltip. Okay, go on.
Layouts hierarchy in JavaFX. In JavaFX, layout defines the way in which the components are to be seen on the stage. It basically organizes the scene graph nodes. We have several built-in layout panes in JavaFX that are hbox, vbox, stack pane, flowbox, anchor pane, etc. Each built-in layout is represented by a separate class which needs to be instantiated in order to implement the particular layout plane.
Yeah, I'm wondering probably they're kind of wrappers which wrap different sections of the page, like a header, footer, things like that. So here they're saying we have edge box, V box, stack pane, flow box. Let's see what they are. So border pane organizes nodes in the left, right, center, and the bottom of the screen. Flow pin organizes the nodes in horizontal rows according to the available horizontal spaces. Ramps the nodes to the next line if the horizontal space is less than the total width of the nodes. Grid pin organizes nodes in form of rows and columns. Edge box nodes in a single row. Pane is the base class for all the layout classes. Stack pane nodes in form of a stack one onto another. VBox organizes nodes in vertical form column. Okay, I think we should stop now and then we'll continue. For tomorrow, you'll be covering convert ER diagram to relations, right?
Yes.
Okay. We'll create the table and stuff also, which we're supposed to
Yeah.
do today. Okay. And the third thing you'll do is just mark the ones that have been asked in the question paper.
Yeah.
Okay. Let me just mark it as red. We done with 174. I think there are 20 to 30 slides more remaining. No, not even 20 to 30. So 25 plus 4. Yeah, around 25 to 30 slides more. So we're going good on that. Cool. Thanks, Amaya. Take care. Bye.
Bye.